So yeah, the question says find the dimension and the SI units of this symbol which stands for viscosity in the following equation. If F is force, R is radius, L is length, V is speed, and R is distance. So we're given the equation that the function f equals minus 2 pi r l v over r viscosity. Now, to find the dimension here, so we are going to do the dimensions one by one. So first, what is the dimension of force? So you can watch my video on dimension to refresh the dimension of each quantity. So dimension of force is ml t raised to power minus 2. So this is the dimension of F, that's force. Dimension of minus 2 is 1. So we have mentioned that dimension of number like constants is 1. So what does that 1 means? It means dimensionless, meaning it does not have dimension. So a constant. Remember, pi is also a constant, which is 22 over 7, approximately 3.14. So it is also dimensionless because it's a constant. You can see, so pi is dimensionless. So meaning the dimension of pi will also be 1. Like that. So we are trying to write each dimension. F is ml t raised to power minus 2. Minus 2 is 1. Pi is 1 in dimension. So dimension of r is also L. Remember, I've mentioned that radius, height, distance, displacement, height, radius, width, everything are a kind of length. So the dimension of radius is length. You can go and watch my dimension video to refresh all this. So dimension of radius is length. Dimension of L, so obviously that is length. Dimension of L. Dimension of R, which is radius. So radius is also a kind of length, is also L. And V, dimension of V is LT raised to power minus 1. LT raised to power minus 1. So now we want to combine everything together. So all these dimensions substitute in the expression. So first, dimension of F, we know it is m l t raised to power minus 2 equals dimension of minus 2, that is 1 constant, times dimension of pi. Pi is also a constant, 1. Dimension of r is a kind of length. It's obviously length is length. V is LT raised to power minus 1. So R is a kind of length. So viscosity. So what we did here now is that we put all the dimension of each quantity. So because we want to find this viscosity. So now you can see here that L can cancel L. So what I will have there now is M L t raised to power minus 2 equals L. Remember, this is 1 times 1, 1. Then L, 1L times Lt raised to power minus 1 times viscosity, because this L has cancelled, so it remains L and L raised to power minus 1. So now this will be mL t raised to power minus 2 equals L square t raised to power minus 1 viscosity, because this one is like L times L square. Now you divide both sides. Remember, you are looking for viscosity, so divide both sides by L square raised to power t minus 1 equals L square t minus 1 so that this will cancel. So viscosity be equals mL t raised to power minus 2 over L square t raised to power minus 1. So now from here, from viscosity is mL t raised to power minus 2 over L square t raised to power minus 1. So we can see 1L we cancel here because we have 2 of it down. So this will be m over L, as you know there is 1L remaining, t raised to power minus 2 t raised to power minus 1. So we are going to use indices. Remember, a raised to power minus 1 is 1 over a. So now if I split everything here to understand the math there, this is like saying m over 1 times 1 over L times t raised to power minus 2 over 1 times 1 over t raised to power minus 1. If I split everything here with times, so that is m times 1 times t raised to power minus 2 times 1 will give us this. Then 1 times L times 1 times t raised to power minus 1 will give us this. So now viscosity is m L raised to power minus 1, because 1 over L is L raised to power minus 1. Then t raised to power minus 2 minus 1. Why is it like that? Because in law of indices, a raised to power s divided by a raised to power y is a raised to power x minus y. Now t raised to power minus 2 divided by t raised to power minus 1 is t raised to power minus 2 minus 1. So follow the rule. So now the viscosity is mL raised to power minus 1 t raised to power minus 2 plus 1. So that will be mL raised to power minus 1 t raised to power minus 1. So finally, dimension of viscosity is equals mL raised to power minus 1 t raised to power minus 1. Now the SI units, of the viscosity here. So m is mass, and mass is in kilogram. L is length, and L is in meter. Then t is time is seconds. So that means we have solved it too.